Hello, AP Stat students. Welcome back to the second installment of 11.1. And what we're going to do here is kind of pick up where we left off with our basics of significance tests. And so what we did last time in video 11.1a is we kind of looked at identifying our parameter and how to set up appropriate hypotheses to test a claim. Okay, so what we're going to do now is we're going to get into talking about, this concept of a p-value and how it will provide us with evidence to either reject the null or fail to reject the null. Okay, so basically we're going to use an analogy of a case in criminal court to kind of compare what we're going to be doing in this inference process. Okay, so let's just say, for instance, there was a murder committed. Okay, and we have a suspect, and he's been charged with this murder, and now he's in criminal court, and each representative of the parties is going to give their or present evidence to the jury, and then the jury is going to decide whether this evidence is convincing or not in order to convict this person of a crime. Okay, so in terms of setting up, say, a hypothesis in this case, the null would be that, all persons are assumed innocent until proven guilty. So our null would be that this suspect is innocent. And then our alternative is what we suspect is true. So we suspect he's guilty. So our alternative hypothesis or a hypothesis would be that the suspect is guilty. Okay, so then we have to evaluate the evidence. So there's a variety of different types of evidence that can be presented in criminal court, and some are more powerful than others. So say, for instance, if we talk about, say, direct evidence, which is like an eyewitness account, we have a person that saw, say, this suspect commit this murder. Okay, it's an eyewitness account. That is very strong evidence versus circumstantial evidence, which is also referred to sometimes as indirect evidence, which are things like, say, we have a murder weapon, we have some footprints in the snow, maybe we have some tire tracks, maybe we have some fingerprints even. And what we would need to do then is deduce that these things are linked together in some way, and they're hopefully linked to this suspect. Okay, so in statistics, what we're going to do is we're going to use this concept of a p-value. So this p-value is going to be our evidence for or against this claim. Okay, so that's, it's kind of a interesting analogy to use, but it's essentially that's what we're doing with this inference process. Is we're setting up these hypotheses, and we're trying to show either that our alternative is true, or we don't have good evidence to say that our alternative is true. So let's get into, more in depth, let's talk about this p-value for a second here. So when we, okay. So when we look at a p-value, okay, the p-value is the probability, and this is computed assuming that the null is true. So it's like, we're assuming that this person is innocent, okay? It's the probability, assuming the null is true, that the statistic would take a value as extreme as or more extreme than the one actually observed. So that would be from our sample data. And we get this number, which we call a p-value. It's a numerical value. And this value measures the strength of the evidence. So since a p-value is a probability, that means then that smaller p-values or smaller probabilities are less likely to occur. So that gives us then stronger evidence to disprove this null, okay? And essentially, if we want to get really into the nitty-gritty of this, the p-value is the conditional probability that given HA is true, so given the alternative is true, then what is the probability that the null and the alternative will also be true, okay? So you don't necessarily need to know this notation, but it's kind of interesting to think about this in a conditional probability sense. Now, I'm going to put a little star by this because this is how we are going to interpret our p-value, and we're going to come back to this little template in just a second. But if we were asked to interpret the p-value, we would say something like if, and then interpret the null in context. If, whatever the null is, then the probability of getting this sample statistic by chance alone is this p-value. And we've kind of talked about that statement before when we were talking about the example of the free throw shooter. Okay, so let's go ahead and move on and kind of dive a little bit more in depth into what exactly are we going to be doing when we have this p-value. Then how do we assess our final answer or conclusion of our significance test? So to determine what p-value is considered small, and if a p-value is considered small, that means that we are going to reject HO. Or large, if a p-value is large, its a probability is large, that means something is likely to happen often, so that means we would fail to reject the null. And we do this by comparing it to a significance level. Whoops. And this significance level is often referred to as alpha, okay? The significance level requires evidence against HO to be so strong that it would happen less than 5% of the time by chance alone when the null is true. When our p-value is less than our chosen alpha, we say that the results are statistically significant and therefore we reject the null. It gives us good evidence when our p-value is less than alpha. Significant has several meanings, and statistically it does not mean important. What it means is it's not likely to happen by chance alone. Also, if you were going to draw conclusions based on statistical significance, the significance level should be determined before the data is produced. Just like we want to set up our hypotheses before we see the sample data or produce this sample data. Also, significance levels are going to range between 1% and 10%. And just as a fun fact, courts will accept a significance level of 5% or lower. Now, sometimes when you are performing significance tests, you will not be given an alpha level. And sometimes you will be assigned a certain alpha level to test a certain claim. So when in doubt, or if the alpha level is not explicitly stated in the problem, what we're going to do is we're going to use an alpha level of 0.05. Okay? So when performing this significance test, basically what we're going to be doing is we're going to be comparing this p-value to alpha. Okay? So small p-values give us good evidence, and large p-values are not good evidence. So essentially, what you want to focus on here is if p is less than alpha, so if p is a very small value and it's smaller than alpha, we are going to reject our null in favor of our alternative hypothesis. And conversely, if the p-value is greater than alpha, we are going to fail to reject HO. So if the p-value is very large, that means this event is likely to occur often, so we aren't going to have any doubts that the null is true, and we will not have good evidence in favor of the alternative. Okay? As a side note, if you fail to reject the null, it does not guarantee that HO is true. So we want to be careful about how we make our conclusions for significance tests. And what I mean by this statement is just because, say for instance, the classic case of O.J. Simpson. Just because O.J. Simpson was not proven guilty in criminal court of murdering his girlfriend Nicole doesn't mean that he did not commit the crime. It's just that the jurors did not think that the evidence presented in criminal court was good enough to prove beyond a reasonable doubt that he committed this crime. Okay? So just because we fail to reject the null doesn't necessarily mean the null is true. When we go about now interpreting the results, what we're going to do is we're going to use this little template here. And what we're going to say is, since the p-value, and we're going to give that probability, is either greater than or less than alpha, and then we're going to conclude we reject or we fail to reject HO. And then further, we are going to say we either do or don't have good evidence in favor of this alternative. Now, there's three things that you need in order to get full credit on the AP exam for concluding an inference test. The first thing is what we call a conclusion. And what that part is that part is going to be this part here, number 1. We either reject HO or we fail to reject HO. We're making a conclusion. Number 2 is we need evidence. And remember that the p-value is our evidence. This number, this probability number, whether that is low or high, is our evidence. So this statement right here is going to serve as our evidence. So you need to be very specific and give actual numerical values. And the third part is called linkage. And what that means is basically we need to interpret in context what this conclusion means. So this last statement right here is going to be our linkage, Okay? Now, if you don't have those three things, you will not earn full credit on an AP free response question about or performing a significance test. If you just simply say, my p-value is small, smaller than alpha, in fact, and therefore I reject HO, that would just be steps 1 and 2. It would not be the linkage step. So you would get a partial credit on that. Okay? Let's go ahead and move on here. And what we're going to do here is we're going to look at 2 example problems that kind of walk us through this whole process. So let's look at example number 1. It says, for a second semester project in AP Statistics, Brandon decided to investigate if students at his school preferred name brand potato chips to generic potato chips. He randomly selected 50 students and had each student try both types of chips. The order the chips were consumed was randomized. Overall, 34 out of 50 students prefer the name brand chips. So, for step number A, part A, it says describe the parameter of interest. So we are talking about a proportion here. We're talking about a part out of a total. So we're going to say let P equal the true proportion of students who prefer name brand chips over generic brand. Okay, so step number 1. Now, remember that always when you're performing a significance test, you always want to state your parameter and you also want to state the hypotheses. So, let's see here. He wants to decide, he wants to investigate he wants to investigate if students at his school prefer name brand chips over generic brand chips. It can be kind of confusing which way we want our alternative to go. So what we're going to assume is that, if there wasn't any difference in preference, that means that, there'd be an equal amount of students that like name brand, there'd be an equal amount of students that like generic brand. So our null is going to be that P is equal to 0.5. That half the students like generic, half like name brand. So this means that we're basically assuming that there's no difference in preference. Okay? Now our alternative is we want to decide, are there more kids that like name brand? Are there more kids that like the generic brand? I suppose on this one we could go with if we were hesitant, we could go with a two-sided alternative hypothesis. But for the sake of this example, let's just assume that we're going to test, since the way we wrote this up, the true proportion of students who prefer name brand chips over generic. Let's go ahead and test to see if P is greater than 0.5. So that would mean that more kids like name brand over generic, okay? So more like name brand. So just to review here, since we are looking at P is greater than, we're going to be looking at this upper right tail and finding the probability that this sample statistic will occur by chance alone if the null is true. And that probability is going to be our p-value, okay? Now, the p-value in this case was computed for us. The p-value is 0.0055. So what we're going to do is we're going to interpret the p-value in context. So you might want to go back to this little template right here. It says interpreting the p-value. So if the null is true, then the probability of getting this sample statistic by chance alone is our p-value. So we're going to sum sum up a statement similar to that. Okay, so what we'll say here is we'll say, what is our null? Okay, our null here is that there's no difference in chip preference. So if there is no difference in the true proportion of students who prefer name brand chips to generic brands, then the probability of observing a sample proportion as large or larger. Now let's go up and look at our sample statistic here. So what he observed is that 34 out of 50 students preferred name brand. So that means that's 68%. Okay? So going back to our interpretation here, then the probability of observing a sample proportion as larger than 68% by chance alone is p-value 0.0055. Okay? All right, so now what we're going to do is work on our conclusions of our significance test. So we're going to look at two different alpha values and how this might affect our conclusion. So what I want you to remember, kind of a side note over here, is that if p is less than alpha, then we reject HO. And if p is greater than alpha, we fail to reject HO. Okay? So remember, our p-value is 0.0055. So I'm gonna write that here, 0.0055, and let's compare them. Okay, which one's smaller? Well, p is smaller, right? 0.01 is bigger than 0.0055. So that means that p is less than alpha, and that means we reject HO. And remember, small p-values give us good evidence. So you might want to go back to this little template. This is what we're going to be following right here, those three steps we talked about: our conclusion, our evidence, and our linkage. Okay? So we're going to say, since the p-value is less than alpha, and then we're going to be specific and give those values. So 0.0055 is less than 0.01. And then our conclusion, we reject HO. Period. And then our linkage, we have convincing evidence in favor of HA. Okay, so what is HA? HA is that more like name brand. Okay, so we have convincing evidence that the true proportion of students who prefer name brand chips over generic brands is more than 0.5. Okay? So that's basically implying that more than half of the people like name brand chips over generic brand. Now let's look at what would happen if our alpha level changed to 0.001. So if our p-value is 0.0055, now this changes our conclusion because now p is greater than alpha. And that means that we are going to fail to reject HO. So the conclusion is going to be very similar with some slightly different vocabulary. So we're going to start off by saying, since the p-value is greater than alpha, so instead of being less than alpha, it's greater than alpha, and then we're going to show our evidence. 0.0055 is greater than 0.001. Instead of saying we reject HO, we're going to say we fail to reject HO. And basically now we're just going to insert this word we do not right here. We do not have convincing evidence that the true proportion of students who prefer name brand chips over generic brand is more than 0.05. So we do not have convincing evidence that the true proportion of students who prefer name brand chips over generic brands is more than 0.5. Okay, so it either could be exactly the same, or I suppose it could be a situation where people actually prefer the generic brand more. Okay, so that gives you kind of an idea of going through that process and setting up the parameter in the hypotheses, and then making a conclusion about the results using evidence. Now we're going to do one more example, and then that will conclude section 1 of chapter 11. So this example says, recall the second example where Mike was testing a new 7-iron. The hypotheses were testing the true standard deviation of the drive distances Mike hits golf balls using his new 7-iron. And we were comparing standard deviation because he wanted his drives to be more consistent. So based on 50 shots with his new 7-iron, Mike got a standard deviation of his drive distances to be 10.9 yards. So recalling from the last example on the first page or whatever, the standard deviation of his drive distances with his old 7-iron was 15. Okay? So we're going to set up our parameter in hypotheses. So we're going to say let standard deviation equal the true standard deviation of Mike's drive distances with his new 7-iron. Okay, so remember that you need to be setting up these hypotheses before you see the sample data. So technically, we shouldn't even see this right here, right? We shouldn't even see that sample result yet. But what we're going to do is we're going to formulate these hypotheses from our assumption of what we think will happen. So HO is what we know to be true, and that's that Mike will drive his balls with his old 7-iron, and these distances will have a standard deviation of 15 yards. So we know to be true. The alternative is what we suspect to be true. So we're hoping that with this new 7-iron and this new technology that his drive distances will be more accurate, meaning his standard deviation will go down. So our alternative is that the standard deviation will be less than 15. And looking at our curve here, we're going to be looking at the left tail, and that's going to give us our p-value, that probability right there. Okay? So for part A, it says a significance test using the sample data produced a p-value of 0.002. We want to interpret this in context. So remember, the p-value is assuming the null is true. The probability we will observe a sample statistic as extreme or more by chance alone is equal to the p-value. So if the standard deviation of Mike's drive distances with his new 7-iron is in fact 15, then the probability of observing a sample standard deviation of 10.9 or smaller, so as extreme or more, by chance alone is, now the p-value, we could say 0.2%, okay? So 0.2% is a very small probability. It's very unlikely to occur. Something happens 1/5 of 1% is very unlikely. So that's going to give us very good evidence to make a conclusion against our null. So for part C, it says our significance level that we're going to use is 0.01. So that's our alpha level. So alpha is 0.01, and our p-value is 0.002, and now we need to compare these numbers to make our final conclusion here. So since p is less than alpha, we are going to reject HO. Okay, so we're going to write up our conclusion. We're going to say, since the p-value is less than alpha, and we're going to give our evidence by being specific, we're going to say p-value 0.002 is less than 0.01, and then our conclusion, we reject HO. Okay? And what this means, since our p-value is so small, this is good evidence. So we have convincing evidence that the alternative is true. Okay, so you can go up here and you can look at, what is my alternative? My alternative is saying that the standard deviation is less than 15. So we can say we have convincing evidence that the true standard deviation of Mike's drive distances with his new 7-iron is less than 15. Now there's different ways that you can state this final conclusion, this linkage part. We could even get away with saying, we have convincing evidence that Mike's drive distances with his new 7-iron are more consistent. And a statement like that would imply that the standard deviation is less than 15. It's less than what it was before. So basically, we're just trying to answer the question. We're trying to, and when we come up with our conclusion, our linkage should always be addressing that alternative hypotheses. So I want to kind of go through those 3 steps, these 3 steps that we talked about right here. And remember that step 3 is always about the alternative hypothesis. So let's just kind of go back and look at this and kind of pick apart, and I want to show you the 3 pieces that are required for a complete conclusion to get full credit on an AP exam. So let's look at this potato chip example. So step number 1 is conclusion. Okay, so here's our conclusion. That's step number 1. Step number 2 is, do we have our evidence? Well, yes, we do. This is our evidence because P is less than alpha. That's our evidence. That's step 2. And step 3 is our linkage about the alternative. So this step right here, all of this right here is our linkage step right here. This is step 3 regarding our alternative. Okay, now in this example here, similarly, now we have a different conclusion, but we still have a conclusion, which is step number 1. We fail to reject HO. We have our evidence right here, and we fail to reject because P is greater than alpha. So this is step number 2. And then step number 3 is all of this right here. This is our linkage in regard to the alternative hypothesis. Since this p-value is greater than alpha, what does that tell us about the alternative? Now going back to this example of Mike's drive distances, so our conclusion now is that we reject HO. So that's step number 1. That's our conclusion. Step number 2 is our evidence. Do we have the evidence piece in here? Yes, we do, since the p-value is less than alpha. So that's our evidence. And then finally, we have our linkage here. So this is our linkage that links our alternative hypothesis. What is the conclusion based on the alternative hypothesis? That is that we have convincing evidence that the true standard deviation of Mike's distances with his new 7-iron is making him more consistent, or that it's less than the value of his old standard deviation for his drive distances. Okay? So next time we meet, we are going to jump into section 2, and we're going to actually carry out the 4-step process for a significance test. And this is the hardest part, the setting up our hypotheses and the conclusion. So that's why we kind of spent all of 11.1 talking about just kind of the basics, what exactly are we going to be doing when we perform this inference test. And the other 2 steps are going to come pretty easy to you. So step number 2 is to check conditions. And, I know that you know how to check conditions by now. And then the 3rd step is the calculation part. Okay? So I hope this video has helped you to kind of better understand where we're going as we move forward. And I hope that you guys have a fantastic day, and I hope to see you soon. Until next time.